Well, hello and welcome here to Future Stage, and I'm super happy and excited that the Latitude organizers want to go a bit more deep tech with one of the most transformative technologies that our planet has to offer at the moment. And my name is Marco. I'm running the investment activities of a specially dedicated quantum fund out of Switzerland, together with a very strong embedded ecosystem in quantum, where we will hear a bit more in a few seconds. And if you look now on what was just said, when is quantum coming? Is it something for the future? No, it's already happening, right? It's transforming industries. And I would like to welcome Thomas and Benjamin. Benjamin, you are number one, a physicist. So the perfect person for here to explain quantum to everyone. You are a venture partner in a deep tech fund, and you're also running a very impressive interview series and newsletter. And in my eyes, as I have seen you over the last 2 years, you have interviewed every quantum company in the world. So maybe you give the audience a bit of an introduction into quantum.
Yeah, hey everyone. Quantum. Why quantum computing? Well, it's just such a very different world once you get into the world of atoms, which is so fundamentally different from what we experience every day. And it just feels not natural to us. It makes no sense from common sense. But I guess we need to just accept that the world looks different on a nanoscale. When you go to the realm of atoms and electrons, where particles could be in two places at the same time, and they sort of could communicate information to each other, even if they're fairly distant. And those kind of weird quantum effects can actually be used for computing, for information processing. And it's mathematically proven that quantum computing can solve certain problems much, much faster than classical computing. Now, it's important to keep in mind that this is a certain problem. It's not like every problem, but it's some very specific, yet practically very relevant problem. While on the other hand, we're not talking about a sort of 10x speed up and it's a nice improvement, but we're talking about an improvement that's day and night. Like, we're talking about problems that a classical supercomputer would not solve in 1,000 years. Like, it's practically impossible. And this is very much relevant if you're trying to develop a, say, new drug, a new catalyst in chemistry, if you're trying to solve hard optimization problems, or even when it comes to encryption, where some encryptions can be broken by quantum computing, while on the other hand, quantum can provide quantum encryption that is much safer.
Benjamin, you have interviewed many startups in that space, right? Not only quantum, but also alternative computing. Can you say a few highlights? So what are your stars in the industry?
Yeah.
And why?
I mean, there's so much cool stuff going on. And one company that, of course, I have to highlight, since I'm a venture partner with Luna Ventures, and for full transparency, we invested in it. It is Semicon. Semicon is a Finnish quantum computing company out of VTT, the same research institute as IQM, but 3 years later, different technology. And they use silicon, so the same material as your standard microchips in your computer, but for quantum computing. So they do silicon spin qubits, and the magic is that it's fully compatible with established semiconductor manufacturing techniques. So the question is really, how do we get many qubits on one chip to do useful stuff? And so being compatible with an industry that has managed to put billions of transistors onto a microchip is obviously very beneficial to put eventually millions and billions of qubits onto a chip. So this is just super exciting on the hardware side, while on the other hand, also software needs to get ready to run on such a quantum chip, where another company that I've seen that is super exciting is Kipu Quantum out of Karlsruhe and Berlin in Germany. What they do is to compress quantum algorithms to make them run in the near term, where you had an algorithm that would require hundreds and thousands of qubits, which could now run much sooner, as it would require just a couple dozens or hundreds of qubits. So those are two highlights that I found pretty exciting, like everything that unlocks quantum and brings it closer to now.
Thank you very much. Thomas, talking about you, you're the COO running an ecosystem out of Basel. You can say a few words about that one. But why do we need, in such a new field of quantum technologies, why do we need such ecosystems, and what are the elements of it?
Yep. Well, what do startups want? They want customers who pay their bills. And therefore, as a corporate, you're not necessarily looking for quantum. You're looking for a technology which solves your problems better, faster, cheaper. And this is where quantum can help. So what we are doing in our ecosystem is actually we're trying to figure out who are those corporates who already have quantum on their roadmap, or who are those who should have it on the roadmap, and make sure we bring them together to our ecosystem and sharing their problems which are unsolvable today. And then on the other hand, we have the startups who have also, for example, not access to quantum computers every day, and we make sure that they do have this access to quantum computers. So meaning, from our point of view, an ecosystem is a platform where we bring different kind of stakeholders together and make sure that they can solve problems together. And this is what we do. And of course, we need money, or the startups need money, and we invest in them. So this is basically in a nutshell.
And how does it look like in reality? Like, what is ecosystem? It's a big word, but how does it look like in real life?
Well, for me, an ecosystem is when A and D does something together without needing somebody who somehow does something else than giving this platform. And this platform in Basel, which we are building up, is on one hand is we build a lot of infrastructure. So meaning, for example, we are having an investment of 700 million building the infrastructure, meaning we're building buildings, we're building offices, we're building clean rooms, we're building labs. And for example, we also have the pleasure to have IonQ from Seattle moving their R&D team over to Europe, to Basel, and implementing at the moment Europe's fastest and largest quantum computer to the heart of Switzerland and Europe.
Great, yeah. Thank you very much. Maybe also, you spoke a bit about time horizons, Benjamin, or about usefulness within the next near term. What does it mean? Like, what is an outlook from your side over the next 5 to 10 years? And maybe you also have a moonshot on the long term.
Yeah, and I guess it's good to put two things into perspective. One is sort of, how could we use machines that we have already today? Even if they're noisy, if they're error-prone, we call them NISQ machines, what can we do with those? And there might be a time horizon of 3 to 5 years where we have enough qubits, enough computing power to just do something useful, which might very well be in chemistry, where you need about 1 qubit for 1 electron, so a couple hundreds of qubits to simulate molecules and understand their properties and energy levels, to do something useful because the materials that you're developing will be valuable. While on the other hand, there's this galaxy brain vision of you have a general purpose quantum computer that could run many different algorithms, that is fault tolerant, that can correct for errors, which is much more potent, but on the other hand also much further into the future, which might be more on a 5 to 10 to maybe 15-year time horizon, where it really much depends on how fast can we bring down error rates and scale up the number of qubits.
Thank you. Thomas, your prospection of the next 5 to 10 years, building the ecosystems alongside these developments, what are you adding to it?
Well, what we see is in banking, there's kind of a tipping point from my point of view. So maybe you all have heard that at the CERN in Switzerland, they opened the Open Quantum Initiative. And the sponsor there was the UBS, big bank out of Switzerland. And what actually made me very much look up to this is on stage there was not the CEO, Sergio Ermotti, or the Chief Innovation Officer, it was the Chief Risk Officer. And so what you see now is, Swiss banks are like lemmings, UBS invests in quantum, so everybody else we need to understand quantum. And there's so many use cases in the banking world where you have a lot of data and you need a lot of computing power to somehow maybe just get your engine better or your risk management better, etc. So this is on maybe the most low-hanging fruit from my point of view. And of course, there are so many other use cases which companies do not have not solved yet. We went out to a lot of corporates and asked them, hey, what are the unsolvable problems you have? And shall we test them on quantum computer? And they very often say, well, we don't think about unsolvable problems because we have enough problems to solve today. And you can use this approach, but we see a lot of corporates who now really want to do this leapfrogging and say, hey, what are really the problems we need to solve on the long term? Let's think of how we can do this better, faster, cheaper, and then they have a big interest in quantum.
You got started, Thomas, in Switzerland so far. You're expanding, right? Also saw Canadian initiatives that you were starting. What's your view on Europe? Also to Benjamin, maybe afterwards. We are in Eastern Europe now. In the middle, there's a lot of things going on in the world. How do you see Europe, your expansion, and what do you plan for the whole quantum market?
Well, what I see, and what we also discuss often with startups, is defense is quite a topic. Quantum seems to be a better solution. And as a founder, you probably need to ask yourself, do I really want to work with defense? Do I want to take this investment from a defense company? And so this is things we see very often happening in not necessarily in Europe, but around the world. So we see quite a lot of countries are afraid of somehow losing something, and they're throwing in a lot of money for creating something, but they don't even know what they want to create. And this is nice, but on the other hand, it's dangerous because you throw away a lot of money. And so this is what I see outside of Europe, I would say. Yeah.
Yeah. On the other hand, when you look at companies in the US, we had some large companies, early successes. Think of IonQ, think of D-Wave, which have become quite large, but then quantum, still takes some time for development. And even in Europe, this ecosystem is developing, and in a more granular way, but also more focusing on different components and building blocks. So now players in the US are actually looking to Europe. When you think of QNect, they're not doing computing, but they're doing communications and memory, pretty much everything else you need to make the quantum internet a reality, which are now looking into Europe for all those different components and buyers and customers. So we definitely have something here in Europe and a genuine chance at building something magical, big and important in quantum.
Okay. Yeah, thank you very much for introduction and warming up the topic a bit. I would say now we get some startups on stage for the audience to dive into quantum a bit more detailed. Thank you very much for having you.
Thank you, Marco.